Okay, now volumetric strain. Now we are looking at work examples. Now this will be your first example. So a steel cube block of 50 millimeters side, cube block, so that means all the lengths x, y, and z are all 50 millimeter long. Side is subjected to a force of 6 kilonewton in tension, 8 kilonewton compression, 4 kilonewton tension along the x, y, and z directions respectively. So you can take the 6 kilonewton tension as for the x, and then 8 kilonewton compression for the y, but then it's -8, and 4 kilonewton tension, that is for the z. Okay, so and then the question asks us to find or to determine the change in volume of the block, taking the Young's modulus to be 200 gigapascal and the Poisson's ratio to be 0.3. So as we know that stress is defined as force over area. So since you are referring to the x direction, so the force that we have to take, that is 6,000 Newton. That is 6 times 10 to the power of 3 Newton, which is also 6 kilonewton. So the area, since it's a cube, so the cross-sectional area of each side, okay, of each of the side is 2,500 millimeter square. So from this you got 2.4 Newton per millimeter square. That is for tension. Then for the y direction, you have to take Fy divided by Ay. So the Ay is 2005, as well as the Az 2500. So the force in the y direction, that is this, that we have considered, that should be -8. So that means this should be -8. So if you don't put a negative sign beside the 8, then the answer you must write it as compression. Either way, you can write it as -8 or -3.2, or you can consider 3.2, then compression. Okay, so you have 8 kilonewton divided by its cross-sectional area. So for the direction, y direction, so remember, for any direct stresses, the area that considered must be 90 degrees or perpendicular to the line of action of the force. Now then you have sigma z, that is the z direction. The z direction, you have 4 kilonewton, that is tension again, divided by the area, 2005, so you have 1.6 tension. Okay, so once you have got the sigma x, sigma y, and sigma z, so let us now consider the epsilon x, the strain in the x direction. We know that this formula, we have derived out this formula earlier, but okay, since sigma y is compressive here, so that is why in the formula you just have to put a negative sign beside the sigma y. This is one of the method. So negative times negative is positive. So you would have sigma x over ex plus Poisson's ratio times sigma y over ey, then minus Poisson's ratio of sigma z over ez. And we know that all the e's are common. They are common. So what you need to do is you just calculate what you have for the numerator. Then you get 2.88. Then for epsilon y, that means the strain in the y direction, from the earlier formula again, for the y direction, actually in the original formula, this is sigma y over ey. We don't have a negative sign. But since there is a compressive, so you just put a negative sign beside it. So you have negative, negative, negative. So that will give you -4.4. And we know that this is only a material, one material itself. So that is all equals to 200 actually. So your ex, ey, and ez are all 200. So your e, so that means it's common. So epsilon z in the z direction, so you have 4 kilonewton. So you have positive, so that means because it's tensile. So when you refer to the z direction, that means this is tensile, so you have to consider sigma z over e. So that is direct when you refer to z direction. So the z direction here will be direct, the rest will be lateral. Okay, so you have negative, negative, but remember again, sigma y, beside that, you have to put a negative sign, and that is equals to 1.84 over Young's modulus E. Okay, so, and we know that the formula for the volumetric strain, actually volumetric strain is equals to change in volume over original volume, and that is equals to epsilon x plus epsilon y plus with epsilon z. And we know that basically we can calculate the original volume, total volume, as height times width times thickness, right? And all the three values are equals to 25 mm. So 25 mm or 50 mm or 50 mm. So you get 125 times 10 to the power of 3 millimeter cube. So that is your change in volume. So you put in everything. So you get this 0.32, okay, divided by 200 times 10 to the power of 3. Then multiply by 125. That means this. Bring it over. So you will get 0.2 millimeter cube. So that should be the change in volume of the cube, for the cube, when it is subjected to, okay, the three forces 6, 8 and 4. Okay, that's for this part. Then the next part here, okay, in an experiment, a bar of 30 millimeter diameter is subjected to a pull of 60 kilonewton, a bar of 30 mm diameter. So that means it's a circular rod or a circular bar. Okay, so what is involved here is the diameter, okay, and the length, So it is subjected to 60 kilonewton force that is acting along, that means along the axis of the bar. The measured extension on the gauge length, okay, the gauge length, that means the original length, 200 mm, is 0.09 mm. The extension, that means the change in length, is this much, and the change in diameter is this much. Calculate the Poisson's ratio and the values of the three moduli, so the E, G, and the K. Okay, so first thing is they have given us the changes in length. How much? 0.09 mm. And make sure the original length is also in mm. If you have 0.09, let's say for example, is meter, and make sure the original length also must be in meter. So both the unit must be equal before you substitute into the formula. So you get a linear strain or a direct strain of this. No units. Remember, strain has no units. And for the lateral, since the direct or the linear is along the length extension of gauge length, along the length, the direct is on the along the length, so the lateral you have to consider the diameter. So to find the lateral strain, you can just simply take the change in diameter, mm, over original diameter, 30 mm. So you have 0.289. That's your Poisson's ratio. And we have got these three formulas earlier in the notes. So you just substitute all relevant values into the three formula. You will get your Young's modulus, your shear modulus, and your bulk modulus. Okay, that's all for this session. Thank you. Please put like and subscribe. Okay, thanks.